the DES key schedule. How to compute the 16 subkeys K1 up to K16 question mark. I start with just showing you how that works. Okay, here we go. 1 second. Okay, so what you see on the right-hand side here, this is a key schedule. Okay, so and I can. Oh yeah, most of you got the book, right? Book is available. So this is figure 3.14 in the textbook. Okay, so this is, what you see on the slide in a somewhat nicer version. That's the key schedule. You see, we start with the original key, and then we see somehow K1, K2 up to K16 is being computed. And now I want to discuss this block diagram with you. So we start with, if you start at the top at K, what might confuse you, if you're very, very alert, there should be a somewhat of a conflict. At the very top of this picture, can you read the bit length of K? What does it say? What's the number there? 64. But what I've been telling you, since last week, where is it here? This is 56 bits here, right? This says 64. So what's going on? And that's a very confusing fact, and it's not very nice if you teach cryptography that the DES standard has as an input 64 bits. So what's happening here? We go in with 64, and you see this block PC1, PC-1, PC-1, and what comes out is 56 bits, right? So and what's happening here is, let's start with number A here. We talk about this PC-1. This is permuted choice 1, which is, again, this block that you see over there. What happens here is this drops bits number 8, 16, 24, up to 64. Okay, effective key length of DES is, of course, 64 minus the 8 input bits that are not connected through, and it's a very weird thing that's happening, is 56 bits. Okay. What's important for you is never ever think that DES has 64 bits. It's not a 64-bit cipher, 56. Okay, and it's or the rest. What happens with the other 56 bits that are connected through? They're also permuted. They're cross-wired in some funny way.